called DISIS. Our panelists today are Vinay Bansal, who is a principal engineer at Cisco Systems Security and Trust Organization. He leads the monitoring program for Cisco's incident command team, and his current focus is on securing Cisco's cloud adoption in public and private clouds, as well as working with various Cisco teams to build secure cloud products. Siddhartha Rao is also a panelist today. He has been an information security analyst on Cisco's computer security incident response team inside of the Incident Command Center for 2 years and has a master's degree from Pace University. His core focus is on creating new plays, investigating security incidents, maturing the security monitoring in the cloud, particularly in AWS, and automating incident response workflows using existing and in-house commercial tools. So gentlemen, without further ado, I'll turn it over to you.
Thank you, Chris, and welcome everyone. So today we are going to be talking about how Cisco has built cloud security monitoring at scale. Few keywords here. One is definitely cloud, other is the scale, right? And as we talk about it, we'll share our experience with all of you. And let's go through the content. So in terms of setting up a stage here, so our team, which is called CSIRT, or also called Incident Command, right? That's responsible for monitoring security across Cisco. So as part of the team, we are a sub-team under that which focuses on specifically the cloud monitoring. And as I think we all understand that cloud is a growing area for almost all the enterprises, right? So there's more and more footprint and workloads moving into the cloud. So it's a very rapidly growing area for all of us. So currently Cisco has around 90 plus offers. And what we mean by offers here are the products like Cisco has WebEx, Jasper, Jabber, a lot of these big offers, right? So which you are probably familiar with, right? Which are cloud-based offers, as well as there is kind of 90 more, right? Which may not be as well known as some of these. So in total, we are touching around 5,000 different cloud accounts across Cisco, which we use, right? And as we go through this whole story and our journey, we'll talk about like how we secure those. And there are three areas or three cloud providers. The main one, which we're going to be talking about, AWS, GCP, and Azure. There are a few others which we use, but those will be the focus for today's talk. From just as I was talking about the scale, right? One of the things you will see is we actually handle almost 100 million events from these cloud accounts on a daily basis, right? And a lot of our work time goes into what we learn and how we automate it, right? And we'll take you through something which we call Place, where we automate all our monitoring as we learn about it. And Chris already introduced us, right? Myself, Vinay, and Sid is also with me. So from agenda perspective, we broke it down into 5 sections. I'll spend some time in first 2 sections on laying out the ground, how we think, right, from strategic perspective, how we plan, because we have to plan not just 1 account or 2 account, but 5,000 account, and it's a constantly growing figure. And then Sid is going to go more into some of the investigation, sharing with you some of the incidents which we see, how we build our place, and how we learn from these incidents. And then we will kind of wrap up with some key takeaways and take some questions. So let's start with scoping of the whole thing, right? So as we talked about, right, this is an increasing number of clouds, right? We see actually this is, I'll say it's a exponentially increasing the number of cloud accounts within Cisco, right, over the last 3-4 years since we start putting some focus on it. And then since it's an increasing thing, right, and there is so much innovation that goes in the cloud, things which were not there last year, there are so many services being introduced, so you have to be always ahead of the curve, right? And then definitely from our team, the CSIRT team, we have a lot of experience in doing on-prem monitoring for our enterprise, right, for the size. And there has been many talks from some of my colleagues in this forum and other form. But definitely cloud monitoring is a little different, right? You have to think differently, and we will walk you through how we do that. And then the other thing is how we have split into 2 kinds of monitoring. One is definitely event-based, but then you correlate some of those things, what we call a behavior-based, where we correlate the data which is coming from our users what they are doing, how they're logging in from their end devices, laptops, to the actual data which is coming from the cloud. Um, and as I said, right, so the key thing here is how you scale, right, for all these cloud growth. Now laying the strategy here, right? So from Cisco, or this is true for any enterprise, when we talk about cloud, right? Those are the three big portions of clouds which we see, right? So what I mean by that is, right, so we Cisco sell offers, and many are built, like I talked about 90 plus offers. Some of the names are there on the slide and the top, right? They mainly run on other cloud providers. We call those offers as offers what we sell. We sell them to kind of get money or revenue back. The middle one, green one, is we use many other cloud providers to run our enterprise. The most common one is Office 365, G Suite, Salesforce.com. We have probably 400 or 500 more of these public SaaS providers, which we use to basically run our enterprise. And then we have our IT environments, which have now cloud form factor using OpenStack, OpenShift, right, database as a service, so that we still run in our data centers. So for this talk, we are going to be focusing on the top portion. The main reason for me to share with you this one is because if you look at work in a big enterprise, people kind of go between the cloud, what we are talking about, right? That's a good demarcation to have. Now, if we zero in on a given cloud solution, right, this is how we generally think from the monitoring strategy. So this is one of the important slides. So let me explain, right? So we start from the bottom, the foundation part, right? The black things which you see on the slide here, AWS, Azure, GCP. That's the first thing to be done correctly, right? To have the SLAs established as part of the contractual thing with these providers. You need to know that, okay, there is a established team who need to be talking on security, or who need to have a handshake on security. Because if you don't do it correctly, what may happen is that different business units, different engineering teams may get accounts, and they're all over the place, right? You don't have proper governance over that. To establish that, you have to have that foundation, right? And that's what you see at the bottom there. Once we have the contractual thing, we have SLAs established with these providers to give security issues back to our team, right, the CSER team, and both ways, and certain SLAs, how quickly they can respond. So that if they find something, they can notify us, and if we need any help, right, we can expect their help in a quick fashion from the security. Over that fundamental thing, you build some base logs which are coming, right? So what we say access logs, like from identity, who is logging in, what's actually happening in your account, what resources are being used, right? So we've used some of the terminology of AWS here, right? So that's the CloudTrail IDM logs, right? What I'm talking about for the access logs. Now the green layer is where where you start using different components, right? Especially if you look at the serverless, or this is the compute tier components, storage tier components, networking components, other PaaS services, and they keep on growing these services, right? Which a cloud provider is providing. So you need to figure it out how you monitor, what are the important logs, because many times you cannot get each and everything, right? But you need to also prioritize based on which is being used the most, right? For example, for any company or for Cisco, we have a lot of usage of EC2, S3 storage buckets, right? We'll talk about that. So we zero in on that, and we see, okay, for these VMs, what kind of logs which we get, right? And that's where we come with the host logs, right? So that's part of our strategy to get OS query and other logs. And as you move up the stack, we need kind of network-based logs, which is VPC flow and others, right? And then you go to this orange layer, which is actually what is the application which you're building, right? So that's not a provider specific. That's, you're building an application, like let's say we are building a ordering system, right? That had its GUI, that have its users coming in, right? So what are the equivalent logs which we need from that tier? Mostly at the web tier, application tier logs, right? So ideally, this is kind of a strategy slide, but I want to share it with you so that you can see, if you have to ideally make monitoring 100%, you cover everything 100%, then you have all the logs required. But in reality, you always start from the foundation. You may not get everything, right? And you keep on maturing. And we spend some time on all those three different cloud providers based on how much is the usage, how much is our footprint. We put efforts in getting all the relevant things. So the other part of the strategy is the thinking about how we show our maturity, right? Like I said, if a new cloud is given to us, right, how we act, right? For us, the first thing is, do we have our analyst investigators, which are part of our CSER team? Do they have a basic knowledge to investigate if they're thrown in a new cloud, like let's say IBM Bluemix or Alibaba? First, the first thing, it's not getting all those logs. It's probably having some technical ability to figure it out, what are different components, how to do forensic analysis, how to have the ability to investigate. That's kind of a level one from or maturity perspective. Then you move to the level two, which is, okay, you have some foundational logs coming. And one of the things which you will see is we try to use Mitre attack framework, the cloud one, especially to figure it out what's our maturity. So if we are covering around 25% of that with some foundational things, that's where we say, okay, we are at the level two ability. And then you move in kind of covering more of the attack framework, having more um, logs and other things, right? And ideally, like level 5, which you always approach towards, you may be at level 3 or 4, right, for us, where you also have everything you need as well as other threat intelligence added to all those logs, where you have much better or probably the best maturity, optimized maturity to do that. So those two should give you an idea that how you may have to think of for a big enterprise, how you build a cloud security monitoring program. Now, let me take you through the architecture and some of how we are hooking things. So this is another of the key slides, right? So it actually gives a one-page view on our footprint on the cloud. So the way to see this slide is you have a log collection happening from these providers. The middle part is the analysis, which are all our plays running and the automation running. And the third part is where we have investigations and reports and working with different what we call tenants or internal teams to fix issues. So if you start back, right, so when we have all these logs coming from different providers, one of the key things which you will hear us talking about is attribution. Because Cisco, big company, right, more than 100,000 employees and so many projects, we need to be able to attribute back to, okay, this account has an issue, which team it belongs to, which particular product it belongs to, what kind of data information is there, is it kind of used for sandbox or testing, or is it a production account? All those things get packed in the attribution. So that's one of the key things for us, right? We spend a lot of time in getting the attribution correct. Once it comes to our sim, which we use, right, that's where we run our plays, right? Now, just to give you a synopsis of, like, when we say around 99 million events per day which we get, right? So that we gave a breakdown there, right? How much we get from CloudTrail, OS Query, Azure, right? And as well as from GCP, right? So it just gives you an idea, right? And then we keep on adding and trying out different tools, both Cisco tools as well as some tools which are becoming mature from these cloud providers to get those events so that we can add those in our telemetry. So now a lot of time is spent for us to build these automated plays, which you see around 107 active plays, which we currently have, and Sid is going to talk more about it. That's based on what we learned from MITRE. Another feedback loop for us is when we investigate, analyze it, right? We call it black box analysis. We'll see, okay, what could have been done better to find these kind of issues early on, right? And that's where we do some analysis, and that gets a feedback loop into building new plays based on what we learn, right, out of the whole thing. Now, moving into giving you a little bit more on how we connect with those three different cloud providers. So this shows a very high level view of if we have connections with the, let's say, the AWS, right? So mainly we get the CloudTrail logs and OS query, which we'll show in the next slide. And then we have a constant flow, right? We use a complex architecture using Kinesis stream and Lambda functions and automations, where we pull in those logs and bring it in, right? Then similar thing which we do with the Google Cloud, which is the GCP, right? But the log format, what they call it, is different, but kind of the purpose is same, right? They have the audit logs, which we get from the another mechanism, which is probably works better for GCP using the PubSub mechanism to subscribe to those so that we can get all those logs flowing in. And the third one obviously is the Azure, right? And I wouldn't go in this, but we get kind of a lot of Office 365 logs also, which we monitor. That's probably not part of this talk today. So we get Microsoft Azure activity logs, right? And then we get those and bring it in. So that's how we bring those logs in. The other one, which is the big log source, is the OS query, right? So OS query is one of the open source agent-based solution which we try to put to get the host level logs. So what we do there is that any host which is coming up, right? One of our strategy has been that we embed the OS query agent in a Cisco hardened image, and we publish those images into each of the accounts. So when a team is launching a image, we want them to be launching a Cisco hardened image, and the OS query automatically comes up, right? And there is some details, right, which is what we call decoration patterns within the OS query, so that it brings its attribution, which tenant ID it's running, what's the instance name, and other details. It pulls in and starts sending it along with the logs back to us, right? So we get a number of logs. Actually, OS query is one of the biggest log sources for us, which is coming back from all these environments. So we are quite mature for OS query on AWS, and GCP Azure, as our footprint is increasing, we are having more and more teams adopt OS query. Now that should give you a good idea of how we think, right? Scaling it, how we architect, and how we bring those logs in. I'm going to pass it to Sid, right, who is going to be talking about now if the logs are in, how we think, right, plays, how we automate, and other things. Sid?
Yeah, thank you, Vinay, and welcome everyone. So now that we have the base of how to get all these things, next is how do we operationalize and utilize these plays, right? So before we go into the actual cloud monitoring play, let's just spend some time in understanding what exactly is a play, right? Simply put, it's a stored query that you can run manually or can be run automatically or set it to run automatically to detect a particular threat against what you're trying to protect, right? And then usually when a threat is detected, you need to have a set of procedures documented right there so that the analyst knows, okay, I see this event, this is what I need to do for this particular detection. That is what we try to answer with a play. Questions like, what am I trying to protect? What are the threats against what I'm trying to protect? How do we detect it? What is the logic that we apply to detect it? And then how do we respond once we actually detect it? This makes up a play. And then once you have a collection of these plays, that makes up your playbook. Next slide. Okay, so we run more than around 300 plays on our infrastructure to protect our infrastructure, and I would like to present an example of one of those plays where the FireAmp is basically the source, the data source that we are going to use, and what is it detecting? It's detecting WannaCry infections on endpoints. That is the play. So how does it look like in our playbook? And so if you see this is an actual example of that play. There is associated information related to that play, the title, description, what does it do, US, cert incident category mapping, subcategory mapping. But what's important to note here is that it's a high fidelity one. So high fidelity play means every single event that comes out of this play is going to be 100% a true positive unless there is a bug in the query logic. And this takes time to get a play to a high fidelity phase, right? It starts as investigative and you have to fine tune it. And as Vinay said about the feedback loop, you learn from your plays and you add in more logic to the play to then make it high fidelity. And then the second thing to note here is, sorry, I just wanted to show the Mitre mapping, that we have this Mitre mapping that Vinay talked about, and this is what it looks like. So now let's look into the actual query and how does it look, and a sample event out of that play. So this is the actual query that is used to detect this infection, and that's the sample event that's coming out of it. You can see the file hash that is being detected. If you look that up in VirusTotal, it'll flag it as WannaCry. And then the computer connector ID on the far right, which is unique to a particular host, so you know exactly where the infection is. And the goal here, or the idea here, is to add as many details as possible in the alert. So an analyst would have all the context required regarding that alert and can take a well-informed decision of what to do next. Yeah, next slide. Okay, so now going into the actual cloud play examples. These are some of the plays that we run against each of these AWS, GCP, and Azure. And if you see at the numbers, currently we have 107, but we didn't start at 107. It was 5 and 2 and 3, and then it started increasing as we learned from our experiences and the investigations and the misconfigurations and all the bad things that are happening. And this goes back to Vinay's slide of having coverage and mapping it against the Mitre attack. And this is how you know where you are. So we are still progressing, but this is where we are at. And in the examples, the goal here to see what exactly we are seeing, so that you get benefited and you look at these things as well. So root sign-in, for example, in AWS is directly a violation against the recommended best practices by AWS. Permissive network ingress, where you're allowing open access to your EC2 instance, and then writable S3 buckets. You have misconfigured S3 buckets where anyone from the internet can write or upload anything to it, which is a significant risk. Then we have Azure, and Azure AD is getting popular, so we had to ramp up our coverage in that space as well. So that's why you see Azure AD, RBAC changes, some of these significant alerts that you want to know about. So yeah, and I would like to add here on the attribution piece, it becomes very important as the scale grows, and we'll circle back to attribution in one of the future slides, in the coming slides, where we'll see why it's so important, and why it's so important to have your attribution organized right from the beginning, so that you don't run around to find who is the responsible owner if there's an incident. Next slide. Okay, so this is the actual Mitre attack matrix. I wanted to introduce to people who may be seeing this for the first time. So the framework lists most commonly used tactics, techniques, and procedures that are used by adversaries. So it's really easy. It's really easy to see, okay, this is what is commonly seen. But then the question becomes, okay, why do I trust this, right? Why do I trust Mitre's list of these techniques to detect? So Mitre actually updates this list biannually. And what they do is they utilize the publicly available threat intelligence, incident reports, and research to actually distill out the common TTPs that are commonly seen used by the adversary. So they keep it relevant, and it's based on actual public research that you can find out there. It's just that they're compiling everything in one place, so that you just have to go there and see what's hot, basically. And we use this matrix as a guideline to map our plays, and it gives a very easy overview of how much coverage we have, where we have coverage, and versus where we have gap, and then we can focus our efforts to address that gap or close out that gap, and that's how we improve the coverage as well. Next slide. Okay, so learnings. from the incident. So as Vinay mentioned, we have a huge footprint, and we have been working seeing a lot of events, seeing a lot of incidents happening in the cloud space, and we were able to see some patterns that were we were able to see some common patterns that are worth mentioning here, so that everyone gets benefited. Next slide. Yeah, so this is a combination of statistics and patterns. So if you see here, the statistics you'll see for the past 6 months or the first 6 months of the year, total number of events coming out of the 100 plus plays. So now you have to understand, we also have more plays, and we also have more people or teams going into the cloud. So this event number is actually going to go up as we scale up. But this, from the recent experience or findings, you see 33,500 as the total alerts, and a major part of those alerts are either best practices violations or not misconfigurations, but policy violations happening, logins without MFA happening, open network ingress, security groups happening, root sign-ins happening, and then even the things like I'm trying to think of another example that we have seen related to the policy violations. Anyway, let's proceed. So a small part of it, about 50 events, are turned into incidents. So this is what we observed in our environment, where these incidents are critical and we need to address this. These are no more best practice violations. These actually need investigations and need to be figured out. Things need to be remediated and reimaged, and keys need to be rotated and stuff like that. So as examples, EC2 abuse reports, where somebody publishes their access keys to GitHub. Those get abused for spinning up huge instances to then run crypto miners. S3 buckets being exposed, or writable. Situations where buckets are exposed and has some kind of source code in it, which is always a risk because you don't know if the source code is actually company property or is it some kind of test scripts there. So things like that. DDoS attempts always happen. Crypto mining, we talked about, abuse of keys, and it's a significant impact because the bills skyrockets when such things happen. So few examples from our recent past of what we have seen and what even you should be seeing to start with. Next slide. S3 buckets. So this was like a case study that we wanted to share, where we started observing a huge number of S3 buckets, and we have around 24,000 total number of S3 buckets in the environment, and we started observing these misconfigured, publicly open S3 buckets out there, and so we started looking at it manually and realized that it was widespread and that it needs to be addressed, but also can't be done manually. So after a point of time, we had to use automation to automate most of the part of the process. So I'd like to briefly explain what the approach was here. Once we figured out the number of buckets we had in our environment, we then figured out which of these are actually public or misconfigured. And fortunately, we had a small number of them that were actually public, and the rest of them had pretty good permissive restrictions and access policies associated to them. Out of those, we found buckets that were really empty, so there's nothing in there to really look at. But if it's writable, then it becomes a whole another issue, because then somebody could upload something like a malware and start hosting malware from there, then that becomes a whole nother issue. But if it's just publicly readable and empty, there's nothing really there. It still is a problem, is a misconfiguration, but then can be prioritized later or can be automated in some other fashion. So that's why you see two categories here: readable buckets and writable, and each affects different pillars of the security, the three pillars of the security. So that's how we started bucketizing them and then prioritizing which ones to look at versus which ones to keep for later. Once we started doing this manually, we found out that most of the process that we were doing, right from detection, investigations, reaching out to the owners, working with them to mitigate this risk, we found out most of the part can be automated, and that's how we proceeded. And now we have an automated pipeline that takes care of these issues. Yeah, this is a fun message that was left by a security researcher for us in one of the buckets that we were investigating. And at the time, we did get some pushbacks from some of the teams, but when we discovered this message, it made our case even stronger about why it's a widespread issue and why we should be addressing it right away. Next slide. Yeah, so an overview of the automated process that I talked about. Run automated scans on all the buckets, we discover a chunk. Fortunately, most of the buckets, as well as most of the accounts in our huge footprint, are related to either sandbox testing. Somebody's learning something, and they don't really pay attention to misconfiguring anything because it happens. They don't realize they quickly want to learn something or try out something, and later it's just left open like that because someone forgot to clean it up. So after finding that exposed number of buckets, we get the feed that then is used in one of our play, which is again a high fidelity play that runs on that feed. So it's basically a data source that is utilized in the play. It gives you a list of buckets that says, hey, these are the misconfigured buckets that I'm going to start an automated process for. So opens up cases, using internal tools. We reach out to the owners, and based upon their response, the case is then either closed or it's escalated if the owner is not with Cisco anymore or the owner is has been changed. Then there is manual interaction where we then need to figure out who is the actual owner or if there is an actual owner. And this is where the attribution again is very, very, very important. It's extremely important when such things happen or when incidents happen in a case where 200 large instances are spun up for crypto mining. You need to be able to be you need to be able to identify and reach out to the owners as quickly as possible, and that's where you realize why attribution is so important. And you need to get hold of people and ask them to take actions to remediate the risk. Next slide. So OS query, Vinay talked about OS query a little bit, which is the host or the endpoint solution that gives visibility into the activity happening on the endpoint. And this is just to show some of the things that we look for on the endpoint. And OS query is an agent-based solution that has like a query packs that run that you can schedule to run, and the query packs basically are related to detecting one particular thing. So it's a free and open source tool, so you can go look at it. It's amazing. And what it does is it converts the OS on which it runs into a database, which then you can query using SQL, like the plain SQL you can use as part of a query pack to then query a particular thing. Let's say, for example, if you want to see any modifications or changes to the SE host file, you can do that for the group changes, or new SSH keys dropped into the authorized keys file, things like that. So an example of this is what we look at, a small subset of a large rule pack that we deploy. Next slide. And this are the associated CSRT plays that actually utilize those events that come out of OS query. So example of what example of OS query based plays that we run to monitor the endpoints. Things like AWS, Linux SSH brute force is a very common one. Linux malicious file, rootkit detection. Just to show like examples of what we run, so that even you get some ideas and could start spinning up such plays as well. Next slide. Lastly, coming to the root causes for cloud incidents, from what we have seen, the patterns that I talked about earlier. These are summarize those patterns into a list that are very widespread in when you move to the cloud environment. These are the actual challenges that you'll see. Misconfigurations, very widespread, very common. You should be always looking at misconfigurations, but because that's number one. Leaked and exposed credentials in Git commits, you'll see this all the time. People using public Git repos. Okay, I forgot to remove the access keys from my code. They get published and they get picked up by attackers and gets abused. And it's very quick. It strangely seems like the bad guys are getting better at detecting these keys somehow and utilizing them before they expire. So keys do have a time frame within which they should be used. It depends if they have time frame or what kind of time frame they have, or if they don't. But they need to be utilized sooner than later. Third one is unpatched vulnerable software on EC2 instances. This is as common as running any vulnerable software on your on-prem solution. But since AWS makes it easier for people to reach out to these softwares because they're running with open security groups, having those patched using the latest and greatest versions of your software, making sure you're running stable patched versions that don't have any known exploits or vulnerabilities is always key. And then lastly, repeating here again, permissive storage policies, S3 buckets, you'll see widespread usage and problem. So it's definitely one of the high risk things to detect. I see it high risk and easy to detect. So it's like an easy win if you get that visibility. And network ingress permissions, definitely. Don't have security groups that are open, reaching out to a port that is not supposed to be open on the internet, and that happens all the time. So some of the key takeaways that we'd like to share from our experience. Next, over to you, Vinay, for the key takeaways.
Thank you, Sid. Yeah. So one of the things I want to stress upon, we talked about how cloud monitoring is different than on-prem monitoring, right? If I look back, if I have to do a data center, right, the top one is generally the number 3 here, which is vulnerable software, right, versus mostly firewalls, right? Those two come at the top if we think traditionally. It versus what you see with the cloud shift, right? Those things are still there, important, but if you see misconfigurations, leaked credentials, especially the way clouds are built all based on APIs, and the responsibility model, right? That shifts the things. Now we kind of summarized what were the key things based on the observed incidents, what were the mistakes made, right, that caused those incidents. I'll kind of summarize and talk about kind of the bigger picture here, which is our cloud program and a scalable cloud program, right? We talked about attribution, right? So at the end of the day, when we start maturing, right, okay, it's becoming better on technology based findings and other things. But one of the toughest thing, which is still for us, is attribution. Cisco being such a big company, we get a lot of acquisitions, right? A lot of different teams may be hosting accounts, creating accounts. Some may be skipping the process. We may not know who has that particular account, right? It's easy to find a issue in an account, right? But who owns that account? How we reach back to that person to switch off that VM or figure it out, right? What's the sensitivity of the data or the S3 bucket? That's always a challenge, right? So attribution is one of the keys, right, which we need to be having foundationally done. The second one is our own flexibility or adaptability, right? Because cloud space is quickly changing. Just in last 2 3 years, things have matured, right? We started with not having a lot of plays, not having a lot of good tools. We started building our own tools to even Cisco acquiring certain companies, and certain products are there like StealthWatch Cloud and AMP for Endpoint and others, which work in the cloud form factor, right, which we're using now. So as well as some of the cloud providers are having more mature services. A good example is Azure Security Center or Amazon's Guard Duty. They were not there 3 4 years back, right, but now they're slowly becoming mature. So for us also shifting our footprint and seeing how we adapt and use these new technologies and quickly changing ourselves. The third one, if kind of nothing else, right? So one of the big indicator, which is even becoming more important even recently, is the bill, right? If someone doesn't have anything to invest in, it's like you should always look at your bill, because a lot of the coin mining activities, we were kind of working on one of the incident which is related to a vulnerable account where someone is used to do a reflective DDoS attack, right, causing a lot of bandwidth usage to that account, right? A lot of the detection could be done just looking at your behavior of a given bill, right? If it is kind of shooting, then some resources are being misused or compromised. Now, that should just in summary, right? So we talked about how we build a scalable solution, thinking about from the architecture perspective, thinking about the strategy, how we consistently learn and convert them into plays, right, and scale it across Cisco. So with that, we are going to be ready to take some questions.
So the first question I see here, and this relates back to something that was said somewhere in the slides leading up to the OS query plays. Ganesh asked if, he said, not sure if I'm getting it wrong, but AWS guardrails provide similar monitoring and alerting. And Ganesh, I'm not sure if you guys have the context there. Ganesh, you may need to provide a little bit more context to the question there.
So yeah, maybe let me see if let me repeat the question, right? I think he may be meaning guard duty. That's one of the AWS service, right? And we should actually. This is where the maturity comes, right? So guard duty is probably came last year, right, as a service. So as the tooling and other things is going to be always maturing, right? So that was not there for 3 4 years back, right? So guard duty is one of the AWS services. It has some features. We use it, right, along with few other things, because every tool has its strengths and weaknesses. So I wouldn't say one tool is just Swiss Army knife and it will do all the things. That's the flexibility approach, right? But I do agree, right? Some of the cloud providers are becoming more mature with their solutions, right? And you need to be quickly adopting to that, right? What is best for your strategy.
Yeah. And one other thing that I would like to add there, Vinay, to what you said, is guard duty. Guard duty is amazing. I love it. And as you said, we have it for certain tenants, but for endpoint, you still need something. For endpoint, I don't think guard duty looks at that. It definitely looks at the CloudTrail and VPC flow and correlates that, yeah, and DNS to give you some good alerting.
Yeah, that's a good point, right? Yeah, OS query gives you a lot more at the host level. Yeah.
So there were some folks who joined a little bit later. To everyone who's here now, if you joined late, just a reminder, if you'd like to ask questions, at the very bottom of your Zoom conference room, you'll see a function right next to participants that says Q&A. Please feel free to type any questions that you have in the box there. You gentlemen were so thorough and informative that nobody has questions. Are you two also able to see the questions? Yeah.
Yeah. I was just going to say, well, I hope it is. Well, I hope it's that way, and not in a way that we were too technical or too fast to understand anything.
So there is a question in here about, is your SIM in the cloud?
So it is not today. That's again being flexible. That's one of the things actually I'm going to sit tonight, and we're building a proposal how we put our footprint into the cloud. So we are looking into it, right? But currently our SIM is in the enterprise. But I think like just the way things are going, you cannot survive with having your SIM just on enterprise, right? So we are looking for a dual kind of architecture where we can keep some of our logs there, right? And there are other factors also that comes into those decisions, especially with GDPR and some of the privacy regulations and geographical affinity from countries like European countries and China. The need for those logs to be staying in, right? And a lot of those regulations are becoming stricter. So those are kind of the forces which are making us think, right? What should be our new strategy to keep the logs? And a cloud-based SIM gives us a very easy way to keep those logs in those particular areas. And there are definitely other advantages for just trying that.
Excellent. What log sources are the most troublesome for you to get from cloud to on-prem?
So do you want to take a stab on that?
So I don't really understand the question clearly.
Okay, let me repeat it, Sid. The question is, which of the log sources are the toughest to get from the cloud?
Okay, from the cloud then. Okay, it's definitely one I could think of is VPC flow, because the nature of VPC flow logs is that they're too noisy, and you can't collect them all, right? The cost of collecting them is also significant. And then what is the value that you actually get just by collecting VPC flow logs is a different issue. So that is one I can think of.
Yeah, that's a good point, right? We did actually start with requiring all the VPC flow, and we actually learned it is very, very large, right? And it was actually our rough estimate. We did a study. It was increasing a cost for the tenant also around 18% of enabling VPC flow and sending and all those. So we have now a requirement, especially for the critical accounts, so that they keep the VPC flow logs within the account. We don't bring it back, but we use it if we need for investigations, right? That's kind of the strategy which we are currently using for VPC flow logs.
Very good. I have another question in the chat here. How do you ensure your users are using the Cisco hardened image?
Yeah, so we have a parallel tool, right, which we actually I presented that 2 years back, called Continuous Security Buddy, or CSB. There's a homegrown tool which looks for I'll call it compliance, and it does around 150 to 200 different checks on each account on a nightly basis. So that's the one which goes in and checks what kind of images are being used by any of the EC2 instances, right? That gives a report. Now, we don't mandate that you can never use this, right? We actually have a requirement when someone can still spin off, right, a non-Cisco hardened image. Or there are some instances, especially when you go into managed services, elk stack, or container-based services, you have to use certain versions of that, right? That's where we have to deal with all those exceptions. So yeah, so main source for us is getting those nightly checks on the environment, giving them report back how much is the compliance level on the EC2, and also look for those exceptions.
What do you think is the biggest perk of cloud utilization?
Biggest perk? It's fun for us.
That's a
right?
tough
It's
one, yeah.
constantly changing. The perk is kind of the excitement, right? It's always challenging. Now in terms of, to me, if I just give you a non-security answer, right? So to me, it is the flexibility, the scale it gives anyone, right? So if we remember 10, 15 years, actually, I remember around 20 years back, I was working on a startup which got acquired by Cisco. And we had to kind of buy a big super dom, and there was so much investment on getting this servers, right? It required almost a $500,000 investment before we can do anything, any development, right? Versus now, even a college kid with hardly any money, right, can open an AWS account and can launch things on big servers, right, and just pay as you use. So to me, that's the biggest advantage, right? And there's kind of a non-security answer. But for me, it is just fun, exciting space, right? Because things change so quickly here. I don't know, Sid, what do you think?
Yeah, I was thinking the same, but not really the same, on the related line. So I was thinking deployment of infrastructure, and there are all these different tools coming out. There's Ansible, there's Terraform coming out that lets you automate and spin up. There's CloudFormation as well. Automate the deployment and standing up of an infrastructure stack in literally minutes, and which is a huge win. And plus, you can do that in any region you want. And some of the services AWS takes care to even sync for you, so you don't have to do that in every other region. It syncs it for you. So those are some I definitely appreciate about the cloud.